Okay, in this video we're going to be adding and subtracting rational expressions. So last time we multiplied and divided them. Now we're going to be adding fractions with polynomials in it. So just taking it back to basics, when we're adding and subtracting fractions, they have to have common denominators. So I can get both of the bottoms in this to be 40. So my left side, I would multiply by 5. Problem is I need to multiply by a form of 1. Okay, because if I multiply by something just by 5, it's going to completely change my number. If I multiply by a form of 1, it's not going to change it at all. My other side, then, I'd have to multiply by 8 over 8. 5 times 1 on top gets me 5. 5 times 8 on the bottom gets me 40. 8 times 1 gets me 8. 5 times 8 gets me 40. A lot of you guys do this part in your head where you automatically make it 40 in the bottom, but technically you're multiplying by a form of 1. Okay, then now that they have the exact same base, we could write it as one fraction with the same base. 5 plus 8 then gets me 13. So this is kind of what we're going to be doing today, where we're getting them to have common denominators, and then we're going to be combining them and simplifying the top. So here's my first one. So my first step when doing these is, do they have a GCF or can they be factored? So this one does not have a GCF and it can't be factored. This one and this one both don't either. This bottom one I can factor, so what multiplies to 2 adds to negative 3. Oops. And that is going to be negative 2 and negative 1. Let's go ahead and do our restriction. So x cannot equal 1 in this situation and 2 in that situation. The other one's going to be 1 again. Remember, it's the numbers that when you plug it in for x, you get 0 down there. Okay, so let's keep working. For them to be added together, they have to have common denominators. Right now, they share this x minus 1. I need x minus 2 on the left side, so I'm going to multiply by x minus 2 over x minus 2. That's still a form of 1, and then they're both going to have the exact same denominator. Okay, so I'm going to get x times x minus 2 on top. You're multiplying it by the entire top, and then I'm going to get x minus 2 times x minus 1 on the bottom, plus I didn't do anything to this other side here. So now that they share that common denominator, you could write it as 1, so x minus 2, x minus 1. I'm only writing one set, I'm not multiplying them together. They have a common denominator. Just like in this one, we just shared the 40. We didn't make it 80. On the top, we're going to get x times x minus 2 plus 2x minus 1. So we're just kind of making that really, really long there. Okay, after you get the common denominators, you're going to simplify the top until things cancel. These will not cancel because by fraction rules, because it's being added with this right here, you cannot cancel. It's only when you get the sets of parentheses like this where things can cancel, when you're multiplying in between all of them and you have all of those parentheses. But otherwise, if it's being added to something or subtracted to something, you can't cancel it. So my first step when simplifying this top, we're going to go ahead and distribute. So I'm going to get x times x gets me x squared minus 2x, and then I'm going to add 2x minus 1 over x minus 2, x minus 1. We keep simplifying the top until we can see if things will cancel. So I can simplify these centers, which will cancel. So then I have x squared minus 1 over x minus 2, x minus 1. We keep simplifying the top because I don't have anything that cancels. What multiplies to negative 1 adds to 0. It's going to be x minus 1 and x plus 1 over x minus 2, x minus 1. And now that they're in the sets of parentheses and they have multiplication in between, we can cancel these two to get x plus 1 over x minus 2. Okay, our x's won't cancel because they're being added and subtracted to something. We don't have the full sets of parentheses that are the exact same for them to cancel. So there's my final answer right here. Okay, my next one doesn't look like I have any GCFs or factoring here, but I do have one right here. If I don't have a number on the back end, looks like there's a GCF that they have in common. And it is x. So I'm going to divide an x out. If I take an x out of x squared, I'm going to have x left. If I take an x out of x, I'm going to have 1 left. X divided by x is 1. Let's go ahead and do our restrictions. So x cannot equal 1 in this spot, and 1 in this spot again, so I don't need to write it twice, and 0 in this spot, because if I plug 0 in for x, it's going to get me 0 right there. Okay, my next route after restrictions is to get common denominator, so they both share x minus 1. The left side's missing x, so we're going to multiply by x over x. So I'm going to rewrite them with the exact same bottom that they share, so I can kind of skip a step to make it a little faster. So they're going to share that common denominator, and now I'm going to do this top here. Remember this x, when I multiply the top, I multiply the entire top by x, and then I have plus negative 2. Once you get common denominators, you simplify the top until we get to the part where things can cancel. Okay, the x's cannot cancel in this situation because it's being added / subtracted from negative 2 right there. Okay, so first I'm going to go ahead and distribute this. So I'm going to get x squared plus x minus 2. Looks like I can factor now. So it multiplies the negative 2, adds to 1. So it's going to be 2 and negative 1. And now that there's multiplication in between everything into my sets of parentheses, I can go ahead and cancel these. I'm going to get x plus 2 over x left. X's will not cancel because this x is being added to 2. So that is my final answer. Okay, this one looks like the only one I can really work right here. So multiplies the negative 4, adds to 0, is positive 2 and negative 2. Let's go ahead and do our restrictions before I start doing a whole lot of stuff. So it looks like I got negative 2 in the first one, that gets me 0, and 2 in the second one. They share positive 2 on the bottom. The right side's missing this minus 2. So I'm going to multiply my top and bottom by x minus 2 over x minus 2. Rewrite it with the shared bottom, the common denominator, which is positive 2 and negative 2. I have an x right here. I add my plus sign in, and then I got the rest of this 1 times x minus 2. Then we just work the top till we get something to cancel. So if I distribute this 1 here, I'll have x plus x minus 2 over x plus 2 x minus 2. I could keep simplifying the top. X plus x gets me 2x. I still have nothing that's canceled. Looks like there's a GCF there of 2, so I'm going to pull a 2 out. When I pull that 2 out, it becomes x minus 1. And it still doesn't look like anything cancels, so that's my simplified answer with the GCF taken out. Okay, again, x's don't cancel because they're being added and subtracted to something, and the sets of parentheses aren't the exact same. Okay, our next one, it looks like we can work this one and this one here. So that bottom left one, they have a GCF of x. If I take an x out of x squared, I get x. If I take an x out of negative 2x, I get negative 2 minus x over, I got a GCF of 2 on the bottom of this one. Okay, so this one's a minus sign, so this minus sign is going to have to distribute to the top at some point because it has to distribute to everything behind it. My restrictions here, the first one right here is going to be 0, because if I plug 0 in for that number, 0 times anything on the bottom gets me 0, and then my next one's going to be 2. Looks like they both share x minus 2 on the bottom. This left side is missing this 2, so we're going to have to multiply by the entire top by 2. And then my right side's missing x, so I'm going to have to multiply this top by x. So the common denominator this time is 2x and x minus 2. So you're basically only writing everything once on the bottom if you get confused. The top, I'm doing 2 times the whole top minus x times x, which gets me x squared. Okay, so let's go ahead and simplify my top. We're going to distribute this to get 2x plus 4 minus x squared. Sorry, this was supposed to be a plus 2. Boopy. So it's not going to be x squared here. Let's go ahead and go back a second. Because that x has to multiply by the whole thing. So x times x gets me x squared. X times 2 is going to be 2x, but you have to distribute that negative. So to make it easier, if I put that x in the front end here, I'm distributing a negative x, so I'd get a negative x squared, and then minus 2x. Okay, that negative has to distribute to everything. Sorry for that confusion. Okay, so this would be 2x plus 4 minus x squared minus 2x over 2x x minus 2. Keep simplifying the top. It looks like 2x minus 2x will cancel. So I would get, I'm going to put the x squared in the front end here, and it's negative, plus 4 over 2x times x minus 2. Remember, to get rid of a negative with the x squared, you can take a GCF of negative 1. Anytime you have a negative x or negative x squared, take a GCF of negative 1 out to get rid of it and make it positive. So I have a negative 1 sitting on the outside. It becomes x squared minus 4 over 2x times x minus 2. Because now we can factor this. What multiplies a negative 4 adds to 0. It's going to be 2 and negative 2 over 2x times x minus 2. There is multiplication signs in between all my sets of parentheses, so we can go ahead and cancel. So my final answer here is this. Again, my x's can't be canceled because that plus sign's sitting right there. Okay, this one, we can simplify this little guy here. So multiplies to 2, adds to negative 3. So minus 6x minus 7. So it's going to be negative 2 and negative 1. Our restrictions are x cannot equal 2 in that first set of parentheses, 2 in the middle, and then 1 in the back end. If you're confused, take it and set it equal to 0 and solve it. Anytime you set that equal to 0, it will always give you the answer that you want. Okay, it looks like they both share x minus 2. This left side just needs this x minus 1. Rewrite it with the common denominator of x minus 2, x minus 1. So on the top it's going to be x minus 1 times x plus 3 minus the entire top of the other one, because it's got to flip all of those signs. Be wary. Okay, so if I simplify the top, I'm going to distribute this negative, and then I also have to FOIL, box up, or distribute that set right there. Okay, so FOIL, F stands for first, outside, inside, last. So x times x is going to get me x squared. O is outside, 3 times x gets me 3x. I is inside. Negative 1 times x gets me negative x. L is last. Negative 1 times 3 gets me negative 3. And then we're going to distribute that negative to flip all the signs. And then we're going to go ahead and combine like terms. Whew. So I got x squared, 3x minus x gets me 2x, minus 6x gets me negative 4x, and then negative 3 plus 7 gets me 4. What multiplies to 4 adds to negative 4 is negative 2 and negative 2. Okay, we got multiplication signs in between my parentheses, so we can go ahead and cancel one of the sets. So this is my final answer. Again, the x's won't cancel because the subtraction of 2 and the subtraction of 1 that's happening. Okay, looks like we can only do something to this. So what multiplies to 5 adds to 6. So multiplies to 5 adds to 6. That is 5 and 1. So it looks like my restrictions will be negative 5 and negative 1. So they're both sharing x plus 5, so I need to do x plus 1 right here. Rewrite it with the exact same bottom, so x plus 1, x plus 5. I'm going to have to FOIL this. So first is x squared. Outside is negative 1 times x, so negative 1x. I is inside, so 1x. And L is last. Positive 1 times negative 1 is negative 1. This negative has to distribute to both of them, so it'll become minus x minus 3. So my x's right here cancel. So I have x squared minus x. Negative 1 minus 3 gets me negative 4. And then I have x plus 1, x plus 5. Okay, multiplies to 4, adds to negative 1. Well, I got 2 and 2 and 4 and 1. And that does not work. So we're just going to leave our answer like this. That's as simplified as we're going to go with it. If you can't find anything else, it's going to work. Okay, this one, we're going to work this as a set and this as a set. So we're going to try to get common denominators in the top first. So it was like when we did 3 and 8, or 5 and 8. We kind of took them and multiplied each side by the same thing. So right now I'm going to try to get them both to have x, y common denominators. So this side's missing y, so I'm going to multiply by y over y. And this side's missing the x on the bottom, so I'm going to multiply by x over x. So y times 1 gets me y, plus, because we got the plus sign, x times x, which gets me x squared, over y times x, because we made the common denominator yx. Now if we work the bottom here, looks like it has a bottom of 1, so if I multiply this by y over y, we can share that common denominator. So here's my big fraction bar. I got 1 plus y times 1 on top gets me y. They share the common denominator of y on the bottom. I hate big fraction bars like this, so we're just going to rewrite it where they're sitting next to each other. So divided by, I'm just going to plop him right next to it, so 1 plus y over y. We can write division signs as multiplication, as long as we flip the back end here. Okay, and then we can write it as a big multiplication thing. So that y will be multiplied by this whole thing, that yx will be multiplied by this whole thing. So if I rewrite it with that y sitting in the front of it, you could have it sitting in the back end, it doesn't matter. Make sure you're multiplying it by the whole thing, and then you check to see if there's anything that can cancel. We can cancel these y's out front here because they're being multiplied to everything. We can't cancel the other set of y's because they're technically being added. So my final answer is going to be this. Y's can't cancel because they're being added, not multiplied. Okay, my next one, it looks like my top fraction's good because I don't have one. So now we just need our bottom one to be the same. So my left side's missing a y, so we're going to multiply by y over y. My left side's, or my right side's missing an x, so we're going to multiply by x over x. Big fraction bar. So I get y times 1 on top plus x times 1 on top over our common denominator this time is yx, because y times x here. We're going to rewrite it with it sitting next to it, so it'll be y plus x over yx. We're going to change it to a multiplication sign, so we're just going to go ahead and flip them. And then we act like it's a big fraction bar and multiply if we can. So x times x is going to get me x squared here. And then y plus x. Our x's can't cancel and our y's can't cancel because of that plus sign right there. They're not being multiplied. If they're being multiplied, then we could simplify further. Otherwise, that is my final answer. Okay, this one, it looks like the fraction is good. They share a common denominator because there's only one fraction. This one we need to multiply by x over x to get it to have that common denominator of x. So I'm going to get 4 over x plus 3, my big division bar. 1 plus 3 times x is 3x. They share that common denominator of x. We write them next to each other. 1 plus 3x over x. We write it with a multiplication sign. We make a big fraction bar and multiply if we can. Remember, these are multiplied by each other like this. So I got 4x over x plus 3 and 1 plus 3x. Nothing is the exact same on top and bottom, so we can't cancel. You can't cancel the x's because they're being added by 3 on the inside. And that is my final answer.